Aptamers, synthetic DNA or RNA molecules that bind to target molecules, can be used to test for foodborne bacterial pathogens, though their specificity, the probability of returning a negative result in the absence of the focal pathogen, in real-world foods has been unclear. Sandeep Somvanshi et al. Fabricated test paper incorporating aptamers targeting strain 0157H7 of the bacteria Escherichia coli. The paper shifts from pink to purple as the aptamers bind to target molecules. Somvanshi et al. Tested the paper in store-bought pear juice they treated with E. coli 0157H7, other strains of E. coli, or other bacteria species. Following the exposure, the paper from the 0157H7 test was purple, while papers from the other tests were pink, suggesting that Choice D, the aptamers successfully bound to E. coli 0157H7 and the tests displayed a high degree of specificity in a real-world food.
So in question number 18, we are talking about aptamers, which are synthetic DNA or RNA molecules that bind to target molecules. And what can they be used for? They can be used to test for foodborne bacterial pathogens. So these can be used to test if there is any bacteria or not in the food. Though their specificity, that is the probability of returning a negative result in the absence of focal pathogen in real world foods, has been unclear. So right now it's unclear. And then they talk about Sandeep Somvanshi, and in his paper they are talking about a particular strain O157H7 of the bacteria Escherichia coli. So the paper shifts from pink to purple. So what is the test? If this bacteria, this specific bacteria is there, the paper has to shift from pink to purple as the aptamers bind to target molecules. So now they are testing it. Somvanshi et al. Tested the paper in store-bought pear juice. They treated with E. coli O157H7. So they take some pear juice and then they treat it with this E. coli, the specific one. And then they also take other strains of E. coli or other bacteria species, and they are testing the same paper with these different strains of bacteria. Then what happens? Following exposure, the paper from this specific O157H7 test, it was purple, while the papers from the other tests were pink. That means specifically it was able to locate this O157H7, and it didn't become purple for the other strains of E. coli and other bacteria species. So it was able to perfectly identify this strain. So which choice most logically completes the text? So if you say D, well done. Choice D is the best answer because it most logically completes the text discussion of aptamers' capacity to test for pathogens in food. The text explains that although synthetic aptamer molecules can be used to test for foodborne bacterial pathogens, because they bind to target molecules, it hasn't been clear how likely it is that they will indicate a negative result when a target pathogen is absent in real-world foods. The text then indicates that Somvanshi et al. Created test paper that changes from pink to purple when aptamers in it bind to a particular strain of E. coli bacteria O157H7 and tested it with store-bought pear juice, that is a real-world food. So they have taken a real-world food. The paper changed to purple when exposed to juice to which the target pathogen. So the target pathogen is specifically E. coli O157H7 had been added, but it remained pink when exposed to juice treated with other E. coli strains or other bacteria species. So based on this result, it seems the aptamers in the paper successfully bound to the target O157H7 and the test had a high degree of specificity. So specifically, not other E. coli, also specifically it was able to change color for this particular strain, providing negative results for samples where the target was absent, even though other bacteria were present, when applied to a real-world food.
Choice A is incorrect because nothing in the text suggests that E. coli 0157H17 differs from other pathogens in a way that makes it more suitable for aptamer-based testing of any kind, and that specificity is likely to be lower when aptamer-based tests target other bacteria. The text simply indicates that Somvanshi et al. Used 0157H17 as the target for aptamer-based test paper in their study and suggests that the paper had a high degree of specificity. Choice B is incorrect because the text indicates that the specificity of aptamer-based tests in real-world foods is uncertain for pathogens broadly, not just for E. coli, and similarity between strains of E. coli or of other pathogens isn't mentioned. Moreover, the results presented in the text suggest that aptamers are actually capable of distinguishing between strains of E. coli, since Somvanshi et al.'s paper turned purple when exposed to E. coli 0157H17 and remained pink when exposed to other strains of E. coli. In other words, the aptamers bound only to the targeted strain, not to the other strains. Further, specificity would be affected if the aptamers had bound to multiple strains and not just the targeted one. That result would cause the specificity to be low.